So we have a question right here. The question say, this is paper 2017. A small AC generator. So we have a small AC generator. So providing RMS voltage of 25 voltage. So or voltage of 25. So it has this stuff here. It has a voltage of 25. So it has a V. So we can write here V potential difference equal 25 V. Okay, and then it's connected across the device resistance. So this stuff here, which has a voltage of 25, is connected to a resistor of 20 ohm. Okay, and the wire is connected to a generator. So this stuff here, this wire is connected somewhere. Let's say outside your generator. Means the source of power, because remember we don't have a battery here. So we take this out and connect to the power source. Connect to the generator, which have a resistance of 0.5. So the generator, which is like external source of electricity, it has a 0.5 volt ohm. So now total resistance is going to be the resistance of the generator and the resistance of this device, total resistance. So now what do you want to say? Write down the total resistance of the circuit. It's easy. Total resistance, we're going to say resistance total. I'm going to take a resistance of the device, which is 20 ohm, and then we plus the resistance of the generator, because it's going to be the generator and this device. What is the generator? 0.5 volt ohm. So together it's going to be 20.5 volt ohm. So this is going to be total resistance. Now we go for the second one. For the second one, say what the average power. So we know average power is easy. We're going to say, power average. So this is a phase of 10.2.1. Power average is 10.2.2. Power average equal to current by here too. So we say power average PF equal, you say, okay, power equal to IV, remember, power equal to IV, but do I have a current? So I have to find current, I have to find what? V. But I don't need V, I don't have a V. So I'm saying, I can use V too, 25, but why I don't change this? Because you know V equal to IR. So I can change V equal to IR because I have my resistance. Look here, go the average power delivered to the device. So since delivered to the device means I want to say what? The resistance of 20. So I'm saying I can use the one with the resistance of 20 because this is the one for devices. So I'm going to say power equal to IV. But let me not use this V. Now say V from Ohm's law, V equal to I R. So I'm going to take this stuff and plug in there. So this will be equal to I and then plus here I R, which is going to give me I square R. So power average equal to I square R. So I'm saying that's my power average. So now we look, okay, so this one I'm looking power average. Do I have a current? No, I don't have. But resistance I have. So which one I'm going to take? Should I take it 20.5 or should I take 20? He said, can I go the average power delivered to the device. So this in the device, the one so we're going to have to use 20 because it's going to be the resistance on the device. So resistance I have 20. So I need to find the current. So to get current is easy, man. So I'm going to say, for me to get power, I need to have a current. Resistance on is 20, but I don't have a current, which is going to be in the device. So now I'm going to say from Ohm's law, so I'm going to have to find the current. Because look here, if I don't plug, look, I'll say power average. Let me say power average equal to current I don't have, and that's how resistance equal to 20. But why don't I take 25? Because I say I got the average power delivered to the device. So it means the resistance is going to be 20, which is in the device. Okay. So the problem now, I don't have a current. You see? So let's get a current, man. So the current, remember the current comes from the generator. So if the current comes from the generator, meaning I'm going to have to use the whole together, the all resistance. You see what I'm saying? Because also you have to involve what the generator means. I have to involve the one for the circuit because the current is going to be circulating around the circuit and from the wire. So I'll take the total resistance is going to be this and the resistance from the generator. So it's okay. So from Ohm's law, I can do here from Ohm's law, V equal to I R. So I want to get what? I. So V, I know my V. What is my V? the generator providing the voltage 25. So this voltage, remember, is not for this, it's for the generator. So I'm going to say, okay, 25 equal to current. What is my current? I'm looking for that. The resistance. So the resistance, excuse me, we have to involve the whole, because the resistance, when this current comes from the generator, is going to be what's going to be resisting the current from the generator is not only 0.5. It's going to be 0.5 and this, the both going to be resisting the current from the generator. So it's going to be, I have to say the resistance I'm going to use is going to be 20.5. Means 20 not 5. So now you divide by 20.5, divide by 20.5. So the current which is going to be flowing is going to be equal to, put that in the calculator. So 25 divided by 20.0 is going to be 1.22 ampere. So this is going to be the current that we're going to come and plug in here. So we say, okay, so finally, power average equal to current, which is going to be 1.22 square times 20. So plug that in the calculator and then get the answer. So plug that and get the answer, man. Plug in the calculator and they're going to get the answer. So that's going to be our power average, which is going to be delivered to the device.